All right, I know you didn't get the first video, but let's try this again. So we're going to look at the last four problems, 19, 20, 21, A and B. A couple students have asked me about this when it comes to log and the inverse and stuff like that. So let's talk about first just what is, how to find the inverse and how to, what is the opposite of log. For example, the opposite of division is multiplication, addition is subtraction, and so forth. Well, the opposite of an exponent is the logarithm, right? So we'll talk about how to write the logarithm and the exponent off to the side. So that's why I'm kind of zoomed out here. I'm gonna left myself a little bit of room. So I'm gonna go off to the right side here and talk about if you have something like this where it's C equals log A B, log base A of B. If I want to rewrite that, or in other words, if I want to get rid of the log, just like you get rid of exponents, or you get rid of some exponents by taking the square root or the cubed root. Well, if you want to get rid of a log, what they do is they do this, which is converting this to an exponent. So I'm going to go ahead and underline all these in different colors. So, or you know what, maybe I'll even write them in different colors. So we have a red C, a light blue A, and a light green B. If I'm going to rewrite this as an exponent, it is going to be where the base stays the same. So A will stay the same. So it's log base A. So the exponent will also have a base A, right? So when you have the exponent, or I'm sorry, the A staying as the base A, the exponent is actually what's being equaled to in the log. So it's A raised to the C power, and that will equal B. So now notice how they all kind of moved, right? So A stayed as the base, so it's log base A. And then if you look down below that, you'll see that the exponent has a base of A. So now this is how you, and I'm putting air quotes here, I know you can't see them, but that's how you get the opposite of this logarithm, right? You take the exponent kind of like this. So now with knowing that, let's go to number 20 and work on finding the inverse. Now notice I skipped number 19, but again, you can, if you have questions on 19, let me know. But again, you can just do the opposite way of what we're about to do in 20. The reason why I wanted to go over 20 because someone had a specific question about, I believe, if I read the question right, I believe it's about this 4 times, this multiplication or this rate that's being added here or being multiplied here. So let's look at number 20. Let's look at this. So it says, what is the inverse of this function? Well, the very first thing I would do is write out y equals 4 times 7x. Now the reason why I would do this is because we talked about this last module. When we find the inverse of something, all we are doing is switching our x and y values, right? So we are just switching our x and y values. So that's exactly what I'm going to do. My next step is going to be x equals 4 times 7 to the y power, or raised to the y power. So now that we did that, okay, so now you're thinking, okay, now what do I do, right? There's a lot of other things. Do I multiply the 4 and the 7? Okay, so don't do that. All right, so I tried to scare everyone right there. Don't multiply the 4 and the 7 because those are different terms. And one, because it has the 7 has a variable in the exponent, right? So we can't multiply those together. Instead, think of PEMDAS, right? Think of please excuse my dear Aunt Sally, or think of the order of operations. So the order of operations is parentheses, exponents, multiplication, division, addition, and subtraction. Now again, when you're going to solve, just like we are here, we're trying to solve for y, we need to do the opposite of order of operations. So we need to start with addition and subtraction. There is none. Perfect. Then we move on to multiplication and division. There is multiplication. So our next move is actually to divide both sides by 4. Now you might be thinking, well, why didn't you divide by 7? That's a great question. But if you divide by 7 to the y power, you're going to bring a variable next to another variable. Now you can do that, but you don't want two variables on the same side. You are trying to get y by itself. So by moving the 4, by dividing the 4 on both sides, it should look something like this. X divided by 4 equals 7 to the y power. Now, once you do that, all you're doing now, so I'm going to zoom out again. I'm going to go here. I'm going to zoom out even further, I guess. Right? Once you're doing that, now we are going to do like the opposite of what we did from the very beginning of this video. So we went from log to exponent. Now we're going to go from exponent to log, right? So now I know all my colors are kind of messed up from the colors to our right, but the base, which I'm going to do in purple, so 7, will stay the same. So I'm going to go ahead and rewrite that. I'm going to say, okay, so this is, if I want to get rid of this y, or sorry, get the y by itself, I'm going to take log base 7. Now remember this right here, what's being equaled, becomes what's in parentheses after the log. So this is log base 7 of x to the 4, or x divided by 4. And this is all going to be set equal to y. I'm going to zoom out again so you can kind of see how that all played out. So again, I just want to kind of reiterate a couple things, right? From the very beginning at the right side, we had a logarithm and we moved it to an exponent, which is what you'll do in number 19. But for number 20, we had an exponent we need to move to a log. So that's kind of how we do it here. Now, the reason why we use log is because there is an x in the exponent, which we call it exponential functions, right? So to get rid of the exponential function, we use logarithms. Now, I know some of you would think, oh, why didn't we take like the square root or the cubed root? Well, the big reason is because it's to the x power. You don't want to take the x root, right? So instead of taking the x root, we actually take the logarithm, and that's what gives us an actual answer here to work with and something we can graph. Because we can't graph the x root of something, right? We can graph the square root, we can graph the cubed root, but we can't graph the x root. So we can graph a log. So that's kind of what we did there. Hopefully that makes sense. I'm pausing a little bit as if I'm in class, but I don't need to do that because you can just pause the video. So let's look at number 21, right? We're going to do A and B. So let's look at B here, or I'm not going to do A. I'm just going to do B because I think B is a little bit harder. But you can do A the exact same way. So we're going to look at B. I'm going to zoom in on B, and I'm going to solve this. Now, for some of us, we know this already, but ln means the log base E, and then x plus 1 in parentheses equals 3.2. Now, when we're looking at this, first thing you got to know is that ln means log base E. So if you don't know that, that's okay. Because if you don't know that, that's something that you can ask, and we can talk about it. And it's called the natural log. That's what that's called. ln is called the natural log, which is log base E. So again, that's something that you should memorize eventually. But again, with us being in this like e-learning phase, like memorization's not really something that we have to worry about since you'll have everything at your fingertips, right? So if we want to solve this, again, we have to do the same thing here. We have to turn it into an exponent. So I'm going to try to use the same color, so I'm going to zoom out really quick. I'm going to use the same colors. I'm going to use this light blue for the base, this C for the exponent, or I'm sorry, this red for the exponent, and light green for the B value. So I'm going to go ahead and zoom in right here. So the base is this light blue, so my base is the same, it's just E, so E will equal, right, that exponent right there. So if I zoom out, right, so that's going to become the exponent. Oops, I did it in light green though. Let me do this here in red. So now this 3.2 is the exponent, and notice my E is still my base, and that will be set equal to my light green here, which is this x plus 1. So hopefully that's a little simple once you get the hang of it, but it takes a lot of practice. So I say simple, but also it takes a lot of practice. So it's something that you kind of have to do on your own. That's one reason why I'm trying to make things a little bit short when it comes to our class, giving you guys more longer worksheets, more problems, and less like videos and instruction, because I think it just takes a lot of practice, right? Maybe that's something I can change though, so we can talk about that as well. But now if I'm just going to solve this, hopefully this next move should be pretty easy. I'm just solving for x, so I'm going to subtract 1 on both sides. So now this just gives us e, and I know I zoomed out, so I'm kind of writing kind of large now. That's okay. E to 3.2 minus 1 equals x. And I'm not going to finish this, but if you just plug that right into your calculator, you can do that. And if you're wondering how to plug that in your calculator, again, you should download that app, Calc84, right, on your iPad. Or if you have a calculator, that works too, right? But if you're wondering how to do that e value, it is second, and then right under log, it says ln, and then you'll see the light blue or the e to the x power in light blue. So second, and then ln, and then you'll get e with a little box where you can put 3.2. So again, this is hopefully going to help you guys a little bit. If we need to go through this some more, we can go through it more, ask questions about the review. I'll just keep sending videos out there on the discussion board. If you have more questions and you're still struggling on things, let me know before our Zoom meet on Monday, so that way I can come with more problems. I'll send out like a worksheet or a PDF with a bunch of this practice, and then I can go over some of that on the Zoom, or talk about what the next week has in store for us. But just let me know so that way I can best help you guys. All right, I will talk to you guys later.